Okay, how do we make a plan that adds up? We put together these efficiency options I've just described, and we glue them to some mix of our renewables, other people's renewables, nuclear power, and clean coal. So let me visualize this for you now. I'll show you a visualization for the UK that I've worked out in a bit of detail, then I'll show you one for the USA as well. So here's a map of Britain visualizing what happens after we've done all the efficiency measures, which have increased demand for electricity. We've now got electric transport and electric heating, so I'm assuming that electricity demand has tripled over today's levels. So we've gone up from 17 kilowatt hours per day per person of electricity to 50 kilowatt hours per day per person. And what I'm visualizing here is a diverse solution. I am not recommending this particular energy mix. It's diverse deliberately so that you can see the exchange rates between the alternatives, rather than me recommending having equal amounts of solar in deserts, nuclear and renewables. I'm showing equal amounts so that you can see the alternatives. So, starting at the top, 16 kilowatt hours per day per person could be delivered to everyone in Britain, which is a country with a population of 60 million, by using facilities in someone else's desert with the area shown here. These are to scale. It's an area roughly twice the size of Greater London. And you would need you would need power lines all the way from the Sahara to Surrey across Spain and France to deliver this very large amount of power. So that's 1/3 of this future plan's electricity from solar in deserts. You can get the same amount of electricity, 16 kilowatt hours per day per person, from nuclear by having a 4-fold increase in nuclear power stations over today's levels in Britain. You can get 8 kilowatt hours per day per person from wind farms by building to scale these things here. Each of these squares is a 100 square kilometre wind farm. And there's some in the sea, there's some in England and Wales, and there's lots in Scotland. My version of democracy says if you're anti-nuclear, which Scotland is at the moment, no problem, you get wind. And you also get pumped storage facilities shown by the yellow blobs here, which are pumping water uphill to balance out supply and demand in the electricity system. So, I emphatically don't recommend this plan, but it does illustrate the scale of what's required. And if you don't like solar in deserts, you can cross that off, no problem, and say we need twice as much nuclear as this shows. So that would be an 8-fold increase in nuclear over today's levels, and we would still have a plan that adds up. Or alternatively, if you say, no, I don't like nuclear, that's fine, we cross out the nuclear, and we need 3 times as much wind as this illustration shows. So you just need to choose where to put the 3-fold increase in wind farms over what I'm showing on this map. That would correspond to what? About a 100-fold increase in wind over today's levels in Britain. So that's a visualization of a possible future for Britain, and it shows you the sort of choices and the scale of what's required. People also talk about solar power being the answer, and they often say what a tiny area in the world's deserts would be required to match today's consumption. And this may be true depending on your definition of the word tiny. This map shows a yellow square in the Sahara Desert and a yellow square in Texas. These 2 yellow squares visualize if you went for a solar-only solution, which of course is silly. If you wanted to power all of Europe entirely on solar, and if you wanted to give a European standard of living to everyone in North Africa too, this yellow square would be the right size, with concentrating solar power facilities. And it is a square that is much smaller than the Sahara, but it is also the same size as Germany. So we can't get away from the fact that renewable solutions do have to be large. And if you say, okay, let's go for a more diverse solution, this solar only was silly, fine. If we go for a diverse mix using renewables, the area will only increase because concentrating solar power was the most powerful renewable on the list in terms of power per unit area. So the total area required is going to be big. This yellow